Hi, welcome to Lesson 4 of the 2D to 3D course. In this tutorial, we will take a look at polygonal modeling. Polygonal modeling allows you to create a model of absolutely any shape and complexity. These can be completely different objects, equipment, characters, and so on. What is polygon modeling about? It involves creating and editing a polygonal mesh. A mesh, or geometry, is a collection of polygons that create the shape of a model. Models, in turn, can be divided by the number of polygons, low poly and high poly. The difference is determined by the number of polygons used to create the model. In fact, there is no clear difference between low poly and high poly. Remember the following distinction between them. Low poly are three-dimensional models created with the minimum number of polygons required to recognize the shape of the object. They are needed to facilitate the rendering process in games, and are also used in a background when the level of detail is not so important. High poly are the three-dimensional models in which the optimal number of polygons is used to recreate the surface, which is sufficient for high-quality display of the shape. The definition is often used to describe models with a high level of detail or hard surface. There is also the concept of topology in modeling. Topology is the optimal arrangement of polygons in space needed to obtain a specific surface. Any surface can be obtained with a completely different arrangement of polygons. We can see this even in the simplest example, a sphere. By changing the topology, the shape of the object is preserved. So, which topology is better? It all depends on how you would like to use the model. Whether it will be animated, used in a simulation, or subdivided using a subdivision surface. For a subdivision surface, topology is very important because it will affect smoothing. We will analyze this in more detail in the next lesson. Correct topology is also used for correct deformation during animation and for creating the desired shape with the optimal number of polygons. In polygonal modeling, there is such a thing as retopology. Retopology is the process of creating a new model based on an existing one, with a more correct and convenient arrangement of polygons for further work. There's an object on the right that's been retopologized. All polygons are optimally positioned and sized. In turn, polygons can have 3, 4, and n sides. A triangular polygon has 3 vertices connected by edges to form a triangular plane. Such polygons are used in game models for optimization purposes. For our modeling purposes, we should avoid triangular polygons, or make them as small as possible. We can achieve this by, for example, placing them on flat areas of a model or hiding them in less noticeable places. We need to do this because, quite often, triangles cause problems when the number of polygons increases, or when deforming and animating the mesh. The same effect happens when working with n-gons. Quadrangular polygon. It is a polygon made up of 4 vertices connected by faces to form a quadrangular plane. It is this type of polygon that should be preferred in the modeling process. A 4-sided polygon will give you a mesh with a clean topology, which in turn will cause it to deform correctly during animation. It also ensures that the model itself will be easier to edit later. N-gon is a polygon consisting of 5 or more points connected by faces. Most often, an n-gon usually means a pentagonal plane. However, it is important to remember that 5 edges are not the limit. When using such polygons, you can run into problems when rendering and animating. So try to avoid n-gon polygons or make them as small as possible. As with 3-gon polygons, position them on flat areas of the model or hide them in less noticeable places. Now let's figure out what you can do with polygons and what tools are used for this. The first thing we will look at is the tools for converting objects to editable polygon objects. For this, 2 commands are used: make editable and current state to object. They allow you to convert primitives or the result of the action of deformers and generators into a polygonal model. Make editable is in the upper left corner, and this command also has a hotkey, C. It converts any parametric objects to editable polygons. By clicking it, the icon of your object will change, and all its parametric settings. There are also the Basic, Coord, and Phong tabs. We got a clearly fixed model. This allows us to edit the axial center of the object. To do this, you need to select the model editing mode and click on this button. Now we can influence the axial center using the Move or Rotate tools. When turning off the Axis editing mode, Axis is locked. Further action with this object will occur relative to the offset axial center. Also, this axis center can be configured using the dedicated Axis Center tool. It's in the main Mesh menu. Moving the sliders, you can adjust the center position. Let's go back to the polygonal object and its functions that appeared during the conversion. An editable polygonal object is a kind of container that stores information about points, how they connect to form faces, and how these faces form a polygon. So the modes for editing points, faces, and polygons become active for a polygonal object. Accordingly, each of these modes has its own editing tools. We will cover them later. The next tool for converting objects into editable polygon models is Current State to Object. It is used in cases where you use deformers to change the shape of an object. If you use a primitive with a deformer and click Make Editable, the primitive is converted to a polygon, but the deformer will still behave as a separate object. To convert both the primitive and the deformer, the Current State to Object command is used. It's in this Mesh menu. It can also be accessed by right-clicking the mouse. Applying it creates a duplicate of the selected model in the form of an editable polygonal object. When using any deformers, they will be applied to this polygonal model and locked. Let's take a look at the polygon editing tools. The basic tools are Move, Scale, and Rotate. You can also apply soft selection to them, which allows you to make smooth changes to the mesh. Most of the editing tools can be accessed by pressing the right mouse button. They differ slightly depending on the selected mode. We already covered some in the last lesson when we worked with splines. Let's switch to the polygon editing mode, as it contains a large number of editing tools. The first tool allows you to create additional points on polygons and faces. When I apply it at the center of the polygon, a point is created that connects itself to the nearest vertices. If you hover over a face, points are created on them. The second tool allows you to close polygonal holes. The next tool, Polypen, is perhaps the most basic one, as it offers a lot of functionality. Polypen works without selection of points, faces, and polygons in all three modes. It can be used in several modes. The most common one is the Points mode. In this mode, we can create points on an empty area that will be connected by faces and close it all by creating a polygon. In the Edge mode, the tool creates faces. To create the next one, you need to start again from the previous one. The Polygons mode allows you to draw with polygons. There are polygon size settings. Let's go back to the Points mode. When we hover over a point, a face, or polygon, they are highlighted and the corresponding icon appears. If the point is highlighted, we can move it by pressing the left mouse button. We can do the same with faces and polygons. By selecting a polygon and pressing Ctrl, the tool allows you to make extrusions. If you do the same with a face, a new face is created, and we can do the same with points. Polypen has an internal binding function. Based on this, you can snap points to other points and faces to other faces, and then merge them. Select a point, drag it to another, and they merge. And you can do the same with the faces. Polypen also allows you to subdivide the polygons. To do this, hover over a face, create a point by pressing the left mouse button, move to the next faces, and create new points. This way we made the cuts on the polygon. Next is the Bevel tool. It allows you to create chamfers on selected polygons. It allows you to customize subdivision. The next tool is Bridge. It can be used to quickly connect polygons. For example, we have polygons that we need to connect to the main object. In Face Edit mode, I select the face of the base model and the face of the polygon. A connection is created immediately. Its advantage is that you can adjust the number of subdivisions of the polygon to be connected. The Extrude tool is used to extrude selected objects. Extrude Inner allows you to extrude into the inside of polygons. Smooth Shift works the same as Extrude. It creates a new surface between adjacent polygons. The next group of tools allows you to cut polygons. The Line Cut tool. Most often it is used to subdivide some parts of the model or to create axial cuts. Let's switch to orthographic projection and apply the tool enabling the Visible Only parameter. Additional faces appeared on the object, but they were created on the visible part of the object. To cut through the polygon, tick the Visible Only parameter checkbox off. The Loop Path Cut tool allows you to create one or more cyclic cuts. The following tools allow you to move points, faces, and polygons. The Magnet tool is the most common one. Sometimes when modeling, you get polygons highlighted in blue. The yellow and blue colors of the selected polygon show the direction of its normal. The positive side of the normal is highlighted in yellow, the negative side in blue. This parameter determines how the editing tool will affect the polygon. To avoid problems during texturing, all polygons should be facing in the same direction. That is, having selected everything, you should not have areas with inverted normals. To align polygon normals, use the Align Normals function. Another common tool is Dissolve or Melt. With their help, you can dissolve a point or a face. Select unnecessary edges. Apply Dissolve to them, and they have dissolved. When it comes to the Melt function, dissolving the edges does not remove the points. If you need to disconnect selected polygons from the main object, use the Disconnect function. If you want these polygons to become a separate object, use the Split function. The last function that is used quite often in modeling is subdivide. By default, it subdivides one polygon into 4 parts. In the settings, we can choose that the subdivision works in the anti-aliasing mode. In this case, the polygons are subdivided in the same way as it should work with a subdivision surface generator. So I often use the generator since it is possible to refine the model without rolling back to the primary stages. There are also sculpting tools for editing polygons which you can use to create or edit the shape of the models. They are in the Mesh menu, the Brushes tab. The set contains all the necessary tools to create simple modifications to models or simple sculpting. They are quite intuitive, and you can quickly familiarize yourself with them on your own. The only thing I want to note is that in my practice I use Smooth most often. It is convenient to use it to correct a bad mesh or irregularities. The rest of the tools are used in some specific cases. Now let's look at the tools for selecting points, faces, and polygons. The main selection tools are naturally Live and Rectangle Selection. Additional selection tools are in the Select menu. Loop Selection allows you to select paths of points, faces, and polygons. To select several paths, select them while holding down Shift. Ring Selection allows you to select faces and points along a circle, but it works like a loop selection when in polygon editing mode. The Path Selection tool. It allows you to interactively select the required lines or points. It functions in the editing points mode and faces. It also contains very useful functions such as Select All and Deselect All. The Invert function allows you to invert the selection. The next group of functions allows you to hide selected polygons. Sometimes part of the model covers a specific area that needs to be edited. With these functions, you can hide some of the polygons and edit the object. Set Selection function creates selection tags for points, faces, or polygons on an object. For example, I select this part of the polygons and apply Set Selection. A triangle has appeared on the object. This is a polygon selection tag. By double-clicking on it, the polygons that are stored in this tag are selected. Let's switch to the Face Edit mode. Select some faces and apply Set Selection again. A new tag is created, a triangle made of faces. We stored the selected faces into it, and it also works for points. If you want to create a new tag, you need to select New Polygons. Deselect the old selection tag and apply Set Selection. Otherwise, the selected tag will be overwritten. These are the tools available for working with polygons. Right now, it is of course difficult to figure out which tool to select, but you will understand this as you gain more experience. So we will cement our knowledge in practice.